Hi guys, it's Mrs. Seitz. Today you are going to be working on an activity that's going to be getting you ready for a lesson about relations and functions. So in order for us to get ready for that, we are going to be kind of working together to figuring out what a mapping diagram is and how to fill one in. So the essential question of this activity says, how can you use a mapping diagram to show the relationship between two data sets? So when I look at this first activity, I can see that this input X of 1, 2, 3, and 4, and I have a blank column for output A. It kind of looks like a table, okay? And we've dealt with those in the past when we were graphing. So I want you to kind of think of that like this is a mapping diagram, but it kind of looks like a table. All right, and how we're going to fill this in is thinking back on something that we've learned about area. So I know how to find an area. Area is length times width. Okay, so if I know that, and in this particular case, let's say, for example, the area for this one, the length is 2 and the width is x. So I can start substituting some values in. So area is 2 times x. Well, if I know the input in our case is 1, I'm going to plug in the input of 1 in for x, and that will give me the output or my answer. So 2 times 1 is 2. So when the input is 1, my answer or my output is 2. Okay, let's do the same thing for input value of 2. So I have to do 2 times 2, and I get 4. Okay, then I'm going to do 2 times 3. And then I'm going to do 2 times 4 to get my outputs. So 2 times my input value of 3 will give me an output of 6. 2 times my input of 4 will give me an output of 8. Okay, so it sounds very similar to some things that we've learned in the past. All right, let's change it up a little bit. Let's say this time the rule is I got to find a perimeter, and this time still the length is 2 and the width is x. So remember, to get a perimeter, you have to add up all the sides. So if this side's 2, the bottom is x. Well, this side's still 2 and the top is x. So if I add up all my sides, 2 plus x plus 2 plus x. If I combine my like terms, 2 and 2 is 4, and x is 2x. Okay, so I'm going to use that rule that the perimeter is 4 plus 2x. If I have an input of 1, I want to see what my perimeter is or my output when the input is 2, the input is 1. So if I follow the order of operations, 2 times 1 is 2, and 2 plus 4 is 6. So my output is 6. All right, 4 plus 2, but then I want an input of 2. So let's see, 2 times 2 is 4, and 4 plus 4 is 8. So the output is 8. Okay, want the perimeter when the input is 3. So 2 times 3 is 6, and 6 plus 4 is 10. Do you notice there's a pattern going over here with the output values? I hope you start to notice that. So this time I want an input of 4. So 2 times 4 is 8, and 8 plus 4 is 12. Okay, let's try another. Okay, this time we're looking for a circumference. Okay, if you can't remember the rule for a circumference, the circumference is 2 times pi times your radius, or r. So to get your output, C, you're going to take 2 times pi times whatever our input is. Okay, so let's try this one out. Let's say I have an input of 1. Well, 2 pi times 1, 1 times anything is just itself, so 2 pi times 1 is just 2 pi. Okay, let's change the input to 2. Okay, 2 times 2 is 4, and I'm going to tack on the pi, so 4 pi. Let's change the input to 3. 2 times 3 is 6, and I'm going to tack on the pi. And let's tack on the 4. So 2 times 4 is 8, and I'm going to tack on the pi, so 8 pi. So you can see the only thing that I'm doing here, instead of using maybe the word X like I've used in the past, is now I'm using the word input. And instead of using the word Y like I've used in the past, I'm using the word output. Okay, let's try one more like this. Volume. Okay, volume is length times width times height. So if I do that, length times width times height, so 3 times 3 is 9, and 9 times h is 9h. So the volume is 9h. Okay, so I'm going to put inputs of 1, 2, 3, and 4 into that. So an input of 1 is 9 times 1, which will give me an output of 9 for the volume. Okay, I want an input of 2. So 9 times 2 will give me 18. I want an input of 3. So 9 times 3, 27. And I want an input of 4. So 9 times 4, 36. Okay, another thing that we're going to need for background today is how many outputs might be assigned to a particular input. Well, if we look carefully, and this is all on that worksheet that you guys have, you want to look and see where the arrow is taking you, okay? So if I start at the 12 and I follow the arrow, the input value of 12 has one output, and that output is 6. Okay, if I look at the input value of 23, how many outputs does it have? It has 1, it's 15. So 1 output. Okay, how many does 30 have? It has 1. How many does 48 have? It has 1. And that value is 13. Okay, let's do the same thing down here. 10, well, it has 0 and it has 1. So it has 2 outputs. It has 0 and 1. 11 has 1 output. It has 0 as an output. 12 has 2 outputs. It has 1 and 3 as its outputs. And 13 has 1 output. It has 2 as its output. Another thing that we need to do as background information for today's lesson is we need to describe patterns that we might see in mapping diagrams. So even though we're using different letters like T's and M's or X's and A's, I still want you to think as the inputs is kind of like your starting place, like your X's, and the outputs is kind of like your Y's, okay? We've seen X's, more X's and Y's than we have any other letters. as our variables. Okay, so when I look at my inputs, it's going up by, let's see, 1, 2, 3, 4, 5, 6, 7. It's going up by ones every single time. Well, when I look at my output column, to get from 8 to 10, I'm adding 2. To get from 10 to 12, I'm adding 2. To get from 12 to the next value, well, you're just going to continue the pattern. So 14. And keep going. Add another 2. And add another 2. And add another 2. So the pattern that's going on with the outputs is we're adding 2. Okay? For our input column 4B, we're adding 1 every single time to go from 1 to 2 to 3 to 4 to 5 to 6 to 7. Okay? For the output, if I start at -2 to get to 0, I'm still adding 2. Well, it's the same thing that's happening in the same thing, right? To get from 0 to 2, it's happening consistently in this one too. So it doesn't always happen that you're always adding 2, but in this particular problem, just like the previous one, we're adding 2. Okay, so in this activity, you learned sort of background information of what a mapping diagram is. It kind of looks like a table. Inputs are kind of like your X's, outputs are kind of like your Y's, and you learn how to describe a pattern. This is all information that's going to get you ready for today's lesson.